This lesson is on the exterior angle theorem, and before we start the exterior angle theorem, we want to first identify what is an exterior angle. And we see we have a definition here. An exterior angle is formed by extending any one side of the triangle. So if I were to draw a triangle here, and if I were to extend any one side of it, so now I'm extending a side of the triangle, that would form an exterior angle. And we see we can do this at any of the corners. If I take the side and I make it go past the corner, I create an exterior angle. Now that we know what an exterior angle is, we have the theorem which states that an exterior angle is always equal to the sum of the two non-adjacent interior angles. So if we look at this image up here, angle 1 is our exterior angle. And if we look inside, the interior angles that are non-adjacent, meaning not next to it, are angles 2 and 3. Well, we can add those up. We can say angle 2 plus angle 3. So to look at another example, which angle is the exterior angle? Well, you would say that angle 4 is the exterior angle. So angle 4 is equal to the sum of the two interior angles that are non-adjacent. That would be 1 and 2, because angle 3 is adjacent to 4. That would form a linear pair. That's not what we want. We want the exterior angle theorem, which says the two interior angles non-adjacent, meaning not next to the exterior angle. So in this case, we would say angle 4 is equal to angle 1 plus angle 2. And just so that we have the vocabulary, some textbooks call these non-adjacent angles remote interior angles. And again, the remote interior angles are the non-adjacent interior angles of a triangle. So now let's solve some problems using numbers. If we look at example 1, we see that angle 1 is the exterior angle. We see that the two angles they gave us inside are not adjacent to angle 1. These are the remote interior angles. So we can add these two up. We can say that angle 1 is equal to 76 degrees plus 52 degrees. Angle 1 is equal to 128 degrees, and that is our answer. When we look at example 2, we say, well, 104 is the exterior angle. So we'll say 104 degrees is equal to, and we want the two non-adjacent interior angles. So we have angle 1 plus 79 degrees. And we're saying, well, let's solve for angle 1. So we're going to subtract 79 degrees from both sides. And we get that angle 1 is 25 degrees. So example 3 now is an algebraic example, but we would set this up very much the same way. So here it's asking for us to solve for the measure of angle 1. We see angle 1 in red, but before we can do that, we need the measurements of the triangle. So to get the measurements, we need to take our exterior angle and set it equal to the sum of the two remote interior angles, or the two non-adjacent interior angles. So our equation would be 5x minus 10, that's our exterior angle, equals the sum of the two non-adjacent interior angles. And now you solve for x. So once you have x, you can say, well, let's plug this back in. So they gave us a 40-degree angle, but they gave us that the top angle was 3 times x. Let's make that 3 times 25, since that was our answer for x, which gives us 75 degrees. And now we can use the triangle sum theorem, which tells us that 3 angles in a triangle add up to 180. So angle 1 plus 40 degrees plus 75 degrees is equal to 180 degrees. And we'll combine our constants, angle 1 plus 115 degrees equals 180 degrees, and subtract 115 from both sides, and we get that angle 1 is 65 degrees. Okay, so here's our next algebraic example. So you can pause the video here, try it, then unpause it, and check your work against my solution. So we see that we have an exterior angle here, and we're going to set that exterior angle equal to the sum of the two angles that are non-adjacent but interior. And now that we have our equation, let's combine like terms. And since we have variables on both sides, let's group the variables. And now let's get the constants away from the variables and solve for x and get 10. Now that you have x equals 10, we can go identify each of the angles and plug in. So angle WXZ, you start at W, you trace it to X, then you trace it to Z, and we see that that's talking about our exterior angle. So WXZ is the exterior angle. Let's plug in 10 for X, so we get 7 times 10 plus 15, which is 85 degrees. Next we have angle YXZ. So we start at Y, we go to X, and then we go to Z, and we see that that is the interior angle of the triangle that is adjacent to the exterior angle. These two angles form a linear pair. So angle WXZ plus angle YXZ is equal to 180 degrees because they form a linear pair. Well, we know that WXZ is 85 degrees. Angle YXZ we don't know yet, that's what we have to solve for. And they have to add up and equal 180. So if you subtract 85 degrees from both sides, you get that angle YXZ is equal to 95 degrees. There's our next answer. Angle Y, when you plug 10 into here, you get 30 degrees. And angle Z, when you plug 10 into the expression, you get 55 degrees. Notice that these three angles add up to 180 because that's how many degrees are in a triangle. So again, here's problem number 5. pause the video, try it on your own, then unpause it to check your answers with my solutions. Okay, so here we see this is our exterior angle. So we're going to write 9x minus 8 equal to the sum of the two interior angles that are not adjacent. Then we would like to combine like terms. 5x plus 7x is 12x, minus 27 combined with minus 32 is minus 59. And now we would like to group our x's on one side of the equation and then put our constants on the opposite side of the equation. And now when we divide 51 by 3, we get x is 17. And when you go back and plug 17 in for each of the variables, for each of the angles, you'll get their measurements. So we're using three-letter naming here. So JKL, from J to K to L. So that's angle K in the triangle. That would be 7 times 17 minus 32. This would give us 87 degrees. Now I'm going to go back and highlight KJL, from K to J to L. So that's our angle J from our triangle. This would be 5 times 17 minus 27, and this would give us 58 degrees. Next is KLJ. If you go from K to L to J, well, that's the third angle in our triangle. So we can say 87 degrees plus 58 degrees plus angle 3 equals 180. So I'll call that angle 3. And when you combine your two angles that you know, you have 145 plus angle 3 equals 180 degrees. And that means that angle 3 is equal to 35 degrees. And that's what we get here. And then our exterior angle is going to be 145 degrees. And we can solve this in one of two ways. We can either take the two non-adjacent interior angles and add them up, so 87 plus 58 add up to 145, or you can take the interior angle that is adjacent and say, well, that's going to add up and equal up to 180, and we can subtract 35 from 180. You have two ways to do this. Either way, it will give you the same answer for your exterior angle. So for problem 6, you'll set up your equation, 18x minus 15, because that is your exterior angle. You will set that equal to the sum of the two interior angles that are not adjacent to it. Combine your like terms. And when you solve it, you should get that x is equal to 5. Plug in x equals to 5 into your different angles, and you get 54 degrees, 21 degrees, 105 degrees, and 75 degrees. So now we have to find the values of x and y. We have two different variables here, and we have to say, well, to solve for them, let's look at just the variables that have x in it. And I see that I have an exterior angle, and I have a remote interior angle. But I also need the other remote interior angle, and that is how I would set up my equation. 9x plus 4 is equal to 4x minus 7 plus 86. So we'll combine the constants together, and that gives us 4x plus 79. And now we'll get the x's on one side. And we'll get the constants on the opposite side. And when you solve for x, you get 15. And now we can use that to figure out what y is. So x is equal to 15, we have that answer. But when we plug 15 into the exterior angle, so 9 times 15 gives us 135 plus 4. So we have 139 for the exterior angle. And recall, we said that these two angles form a linear pair. So 7y minus 1 plus the exterior angle, which is 139, have to add up to 180 because these are a linear pair. So now 7y, and when you combine negative 1 with 139, gives you plus 138 equals 180. Subtract 138 from both sides, and you have 7y equals 42. Divide both sides by 7, and y is equal to 6. And there's your x and y answers. So here's our last example. Reading it, it says if line L is parallel to line M, find the values of x and y in the diagram below. So we have parallel lines here. Let's mark them in our drawing with parallel marks. And now we have those two parallel lines. We can say that this side of the triangle is a transversal because it intersects those two parallel lines at different points. So that's our transversal, which means that alternate interior angles are congruent. So we can say 5x minus 8 can be written here. And now we can say, well, these three angles of this triangle, if I were to draw that triangle out here, just so that it's not too much to look at in the image, we have 63 degrees. We said that this angle here was 5x minus 8 because of the alternate interior angles theorem, and that this angle here was 7x minus 31. So we're going to use the triangle sum theorem, which says that three angles in a triangle add up to equal 180. And now we can combine our like terms. We have 12x. We have minus 31, and minus 8 is minus 39, plus 63 is plus 24. And now we can subtract 24 from both sides. And dividing 156 by 12 gives us 13. So now that we've got that answer, we want to focus on the y variable. And what we'll see here is that this expression with the y variable is an exterior angle. So let's again draw this triangle. We have the 63 degrees. We have the 4y plus 27 degrees. And we need the other angle that is not adjacent but interior. So to get that, we have to take our answer of x equals 13 and plug it into 7x minus 31. And that gives us 60 degrees. So now we can write our exterior angle is equal to the sum of the two non-adjacent interior angles and subtract 27 from both sides. And we have 4y is equal to 96, or y is equal to 24. So that's the end of this lecture. Now you can go on and complete your practice and homework, and then check your answers with the answer key posted online. Email me if you have any questions.